Thank you very much. I am honoured and a little surprised at how many of you are here, so thanks for coming. I'm Adam. I'm based in Vancouver, Canada. By day, I work at the Rust Foundation on ecosystem security. My main focus is crate and supply chain security. So this talk is it says crate security in the title. It's kind of a Trojan horse, or it's kind of also just a supply chain security talk to some extent, but we're obviously mostly going to focus on crates because we're at Rust Nation. In practice, this job mostly means, finding the obvious cryptocurrency wallet theft code in people's build scripts that they publish to crates.io. By even earlier in the day, because the team meetings are at 7 o'clock Pacific time, I'm also a member of the crates.io team. I love that meeting time. I wouldn't change it at all. It's not terrible. I should probably also preface this by noting that nothing I'm about to say is the official position of the Rust Foundation, in spite of the fact the logo's there and I'm wearing this t-shirt. I am speaking in my own capacity. So if I say something smart, it probably is something that the Foundation believes in. And if I say something really dumb, that's definitely me. So let's talk about the agenda for this talk. It's going to be a pretty wide-ranging talk on supply chain and crate security, on these topics in general. I'm going to cover two general areas. Firstly, supply chain security in general, and I'm going to cover some of the work I know of in Rust specifically in the crate ecosystem that's working to improve the state of the world there. Secondly, I'm going to dive into how we can think about analysing our own dependencies and understand the security situation that we're in and the posture that we're in, and talk about some tools and techniques that you can use to hopefully integrate into your own security and sustainability story. And then at the end, because, as a bonus, I'm going to talk just a little bit about crate selection as well, because that's an important part of this as well. If you have multiple options for crates, what do you pick? So let's start at the beginning. The general concept of supply chain security isn't a particularly hard one to wrap your head around. Everything that you build uses something else that has to rely on something else, and all of those things have to be secure. And of course, reliable, of decent quality, all those sorts of things. And practically, particularly at a Rust conference, nothing in modern software gets built without some level of dependency on something else. Like even if you're writing embedded code in a no standard environment for some sort of chip, you're still relying on the Rust compiler. You're still relying on, if you are pulling any crates, you're relying on the chip microcode being implemented correctly. It's dependencies all the way down, basically. So you rely on all these things being secure and correctly implemented. But of course, practically, most of us write Rust code that pulls in other crates, that depends on other crates. I'd actually go so far as to say the crate ecosystem is one of Rust's biggest strengths. My Rust origin story was working on a C code base and basically just not wanting to implement data structures ever again in C, basically. So I was like, okay, let's. There's this thing called crates, and they have hash maps and things like that. This is great. So that was kind of how I got started. And it's like, I never want to write serialization code ever again without Serde, for example, or mini Serde, or whatever your preference is. These crates obviously all have their own dependencies as well. If we enable derive in Serde, there's about 7 dependencies there, which means that we're not pulling in one dependency when we put Serde in our cargo.toml, but we're also pulling in all of these. So this can add up. Let's look at Z really quickly, which is an editor written in Rust that I suspect most of you have heard of, if not played with at this point. It's Rust from the ground up. It has very few native dependencies. It's I don't actually use it day to day, but it's pretty cool. The top level Z crate has, as of yesterday, 122 direct crate dependencies, give or take, since there are some platform specific ones. But once you factor in their dependencies and their dependencies and so on and so forth, that adds up to 882 unique crate dependencies to build a nice but an IDE, not even an IDE, an editor, right? These higher order dependencies, just most of you will know this, but they're usually called transitive dependencies, and that's the term I'm going to use as we move forward. So if I say transitive, means higher order, indirect, whatever you want to map that to in your head. I'm not going to bother trying to show the actual cargo tree output here. I did try to get cargo dep graph to generate a dot file. It took about 30 seconds to generate the dot file. And then when I ran it through GraphViz, I found out that Cairo has a maximum dimension of 32,767 pixels in one dimension. So it's all really low res. Like, this isn't pixelated because I'm bad at this. This is pixelated because GraphViz literally hit the limit of Cairo. My point is, it's quite a lot of dependencies, right? So, we've got to think about that. But even simpler projects like BAT, which is a better cat alternative that I like using, has 30 direct and 119 transitive crate dependencies. Most of them are like ones that I also recognize from things I do. Like, a lot of my day job is writing little command line tools and servers and things like that to drive dashboards and do security analysis and things like that. So it's normal for me to pull in things like clap and this error and so on. And that's before we even think about async, which BAT doesn't have to get into at all. So the average project I work on, probably has 200 to 300 dependencies. Once you pull in, Tokio, futures, and, the quality of life things like ITA tools that, I just never ever want to live without ever again, basically. I could go on, but you get the general idea, right? So I'm going to posit three things at this juncture. Okay, so number one, if you think about all of those dependencies, you don't control that code. Now, I'm generalizing a bit. In the case of Serde, which we had earlier, David Tolnay probably actually does. Plenty of those Z dependencies are actually other crates that Z Industries themselves wrote for this project. But even then, the vast majority of those 882 crates are not, ones that Z owns. But it gets worse. Number two, you haven't read that code. I haven't. So I mentioned clap earlier, right? I use that for all my command line argument parsing in Rust. It has something like 77,000 lines of Rust code in that project. Now, look, I've met Ed Page a couple of times. I trust he's writing good code. But let's not pretend that I've reviewed clap in any actual detail. I've never contributed to that project. I think I cracked it open like once just to figure out a corner case in like argument parsing. But like most of you here, I don't, just get to write Rust for fun, right? Like, it is fun. Don't tell my boss. He's at the back, but he's not listening. It's okay. But I have projects, and projects have deadlines, which means I don't have time to actually review that code. So, okay, maybe if you're at a big tech company, maybe life is better and you do. And by... Good, I'm glad someone got the joke. By you, what I really mean is your collective hive mind. We'll come back to that. But I work at a plucky non-profit. I definitely don't have time to review clap in detail, let alone the other 300 dependencies that I'm depending upon, right? We're busy at the Rust Foundation. We have trademark policies to write. So how do we make good decisions? Well, we'll come back to that. First, an aside. There's one really obvious take here, which is, do we actually need all these dependencies? Armin Rodiker, who many of you will know as Mitsuhiko, wrote about this just last month, in fact. His thesis, which I'm going to paraphrase and butcher, so if Armin ever sees this, I'm really sorry, is basically that while you can't get rid of dependencies in general as part of modern software building practice, you should build it yourself more where you can. And particularly if you're an author of a reasonably foundational crate. His own Mini Ginger, for example, only has one dependency, and he's actually trying to get rid of it. There's a whole aside in his blog post about basically just that. It's a really interesting blog post. I personally have mixed feelings on this, honestly. I love the entire idea of projects like Serenity OS, right? Where it's basically a case of, hey, I'm just going to build an entire operating system from scratch so that it's done the exact way I want. But to a first approximation, none of us actually have time to do that. I certainly don't, sadly. It sounds like fun, though. At the other extreme, of course, you can go for we're going to use all the dependencies. And you have things like leftpad, which most of you will probably remember from 2016, where somebody had a node package called leftpad that just leftpadded a string. And they, after actually, funnily enough, a trademark argument with an unnamed company, trademark's weird, the author pulled it and deleted it from NPM, which at the time had no guardrails around package deletion. Which essentially resulted in the entire node ecosystem becoming unusable for at least a couple of hours. That was a day. So you probably don't really want to pull in a dependency for every possible thing, right? Although if you do, I'm pleased to tell you that crates.io has not one, but two crates to tell you if a value is false. Well, exactly. Look, if anyone was in Marco's talk earlier, release please can help you add another one really quickly. But, in general, I think being mindful of the size of your dependency graph is probably a good idea, particularly given that transitive dependencies tend to end up a little exponential sometimes. How you balance that is kind of an individual thing, or, if you work in a corporate, probably a corporate thing. I probably personally pull in more stuff than, say, Armin does, but that's because I'm, A, not as good a developer, and B, more importantly, much lazier than Armin. But, you can make your own choices, right? Also, just a little aside to the aside, some ecosystems deal with this by having just more things in their standard libraries, right? Python, is one of the leading examples of this, where it's got its batteries included philosophy. It's even in the tutorial. It literally says batteries included. If I'm writing a small Python tool, I don't have to pull the clap equivalent in because argparse is right there in the Python standard library. The Python standard library has all sorts of stuff. It's got tons of things. If you want to read a mailbox file from 1994, trust me, it's in there. Then, there's even things like, there are built-in standard exceptions to inherit from, so you don't have to pull in like a this error kind of thing, and so on and so forth. And then on the flip side, other languages are even more minimal than Rust. Lisp implementations famously, have like maybe a couple of functions in their standard library. C's standard library is also notoriously small, but that's more historical than philosophical, right? Maybe it's become philosophical over time, but it certainly wasn't back when you had, mainframes and dinosaurs roam the earth and so on and so forth. So Rust, of course, is somewhere in the middle, probably on the smaller side. Definitely on the smaller side if you're in a no standard environment, but that's kind of obvious. I know there's quite a bit of interest out there in dealing with this. I've heard of multiple projects from some corporates and some in the community trying to essentially create or curate an extended standard library with sort of this vague hope in the end of getting some sort of official stamp of approval from the Rust project. Good luck. But, that is a possible option. But one manifestation of this that does exist today is things like bless.rs, where people have tried to collate and list the crates that, most of us tend to just reach for anyway as best practice, like clap and serde and maybe this error or maybe air or maybe color air, depending on, which way you lean in terms of error handling. And I think some of these are generally useful starter packs, and I'll come back to this at the end. But they're also not a panacea. All right, let's unwind the stack back to the main talk. Dependencies, they exist. We probably can't get rid of them. All right, so the next obvious question is, why does this matter? I'm not going to dwell on this too much because I think the recent, history of supply chain attacks is pretty well understood by most developers. But we've seen, some examples in recent years of attacks, by individuals, by organised crime, definitely by state actors looking to do nefarious things. The famous one from last year, of course, is XZ, which I get pronounced correctly because I'm in the UK, thank God. A seemingly friendly open source contributor became a maintainer of this project, which is a fundamental part of pretty much every Linux distro and operating system except for Windows, and injected a backdoor into a release. So, I'm not going to go into any more detail on that. I've heard of betting pools about which country was responsible for that. But, this was the real example that sort of made a lot of people who were only half paying attention last year real panicky all of a sudden. Other package registries in other ecosystems have also seen pretty well publicized examples of malware being hosted on them. This is an advisory for one in PyPI. There's a popular Python package called Fabric. And so somebody published one called Fabrice, which provides the same functionality, but also comes with a persistent task to extract AWS keys from your home directory. Obviously, the idea being that, if you are from a country where Fabrice is a common name, you might just, muscle memory it when you're pip installing. And while they're less common in the Rust world thus far, we're not immune. This is a recent example from last week called RANDs, which, I'm sure you've all heard of the RAND crate. Probably most of us use it on some level, if directly or indirectly. So this would give you the same functionality as RAND, but it would also link your Rust application with a static library that would download and execute something that probably wasn't doing anything good. I'm going to guess it wasn't putting bunnies on your wallpaper. So, this is one of those things. It's not the only one. We don't get a ton of malware on Crate.io compared to, say, some of the other ecosystems, but it's not zero. Here's a set of crates from 2023 that tried to exfiltrate secrets from users as well. Fortunately, they were really badly written and didn't really work. Even more fortunately, the person who published them forgot to turn on his VPN for one of the publishers. That was a really good email to write to a college. You know, you can obviously see that these are kind of like trying to imitate, you know, better known crates in the Rust ecosystem. This doesn't work quite as well in Rust because Rust imports obviously actually use the crate name. But if you're using an IDE and you're not really paying a lot of attention and, you know, you're just like, you know, import whatever the thing is, well, maybe you can fall for it, right? I mentioned big tech earlier, and I will again now. Big tech, as it turns out, really cares about this stuff now because there's a lot more requirements, there's certifications, there's attestations that you have to make now to say that the software you're building is secure for a lot of, like, you know, governmental contracts and things like that. Regardless of one's general feelings on big tech as a whole in 2025, this is good because this is work they're funding and involved in, and they're trying to help with this problem, making the supply chain more trustworthy and secure. And I'm going to talk more about some concrete examples of this shortly. So there is a lot of effort going into mitigating supply chain attacks right now. I don't have time to catalog everything that's going on, and frankly, I don't know everything that's going on because there's just a lot happening. But I'm going to talk about a couple of projects I know of just really quickly that are hoping to improve various aspects of this in the next year or so. In terms of changes to the Rust project itself, the first one that probably is going to come is this trusted publishing RFC, which is basically a way of facilitating the building of release artifacts, so in this case crate files, from trusted environments such as, you know, GitHub Actions, without needing to keep long-lived access keys or credentials in your security vaults, because that becomes really easy to get stolen. This was written by my Crates.io teammate Matthew Trostel. It was approved late last year, and implementation on this is hopefully going to start real soon now. Yeah, and hopefully this will be out at some point soonish. My colleague at the Foundation, Walter Pierce, and Josh Triplett, who probably needs no introduction, are working on an RFC to use Tough, the update framework, to provide a chain of trust for signing crates and Rust releases. Initially, this is just going to be used to ensure that you can verify that crate files came from, you know, the real crate file that got published on crates.io. So when you're using mirrors and proxies and things like that, that's extremely useful. But in the longer term, this should also provide the basis for crate authors to themselves attest that, you know, they published the thing they meant to publish and signed the things that they published. And then, of course, there's the defensive aspects. You know, there are multiple groups out there who are scanning crates as they're published for various purposes, finding malware, looking for security vulnerabilities, analyzing code quality more generally, investigating sustainability of, you know, various crates and that are key in the ecosystem, and so on and so forth. Again, there's too many of these to list all of them. We at the Rust Foundation are, you know, investing in infrastructure to do more crate scanning for malware. This was a project I did last year to look for repo provenance, so basically comparing crates to, this is an old screenshot, I know those version numbers are out of date. Basically comparing crate files to the repos upstream, because that was part of the XZ incident, for those who remember that, is that the tarballs that were published for XZ 560 wasn't the same as the code that was in the repository. So a lazy person who was just reviewing the repository would have missed that there were bad things happening. Also, it's pretty subtle, so they might have missed it anyway. But so yeah, we've got a whole bunch of ongoing work going at the Foundation. There's also OpenSSF, who are the Open Source Security Foundation, which is part of the Linux Foundation. They have infrastructure in place to build crates and other language packages in a sandboxed environment and basically see what they do. So, like, you know, if a crate tries to go out and, you know, steal your AWS keys, then in theory, that's the kind of thing they're looking for. This is obviously a particular concern in Rust because of build.rs scripts and proc macros, because they run unsandboxed at compile time, and worse, a lot of the time in Rust Analyzer in your IDE. So it's alarmingly easy for somebody to basically execute code on your machine as you're developing and building stuff. So it is critical that this kind of scanning takes place. There are also for-profit companies involved in scanning the crate ecosystem. The set of crates from 2023 that I mentioned was a report from a company called Phylum, who are really helpful people who've worked in the past to find and report malicious crates. At least two FANGs have projects along the same lines going on in their open source project offices. So there are many eyes watching, but that doesn't always prevent things from slipping through. All right. So now I've scared you all. More accurately, now that I've run down supply chain security as it pertains to Rust, at this point I hope you're asking, so what can I do in my own project and my own work to improve things? So, as we discussed earlier, the naive approach of, I'm just going to review every dependency probably doesn't scale most of the time. If you can do that, great, do that. That's awesome. But the good news is there's actually plenty of data and stuff out there that you can use to make informed decisions and either benefit from the work others have done, or at least use it to make more targeted decisions about, if you have limited review capacity, what could you go look at that's actually the most useful. So let's start at a high level. First thing, obviously, you've got to identify the crates you depend upon. Direct dependencies are easy because they're in your cargo.toml, usually. But we also need to know about the transitive dependencies. There are lots of ways to get that. You could parse the lock file, you could generate an SBOM, software bill of materials, which if you work at larger places with compliance requirements, you might have to do anyway. But as I briefly demoed earlier, Cargo comes with Cargo Tree and it will give you the basic list. You don't have to reinvent the wheel here. A harder question to answer is which dependencies are most important to you. Direct dependencies are the obvious ones. You can also pull apart the output and say, okay, well, these crates appear multiple times. Maybe this is kind of foundational to whatever I'm building. I mean, even in this list, you can kind of see that's kind of, could be misleading. You wouldn't want to take this just on faith. Proc macro 2, probably we don't have to go invest a lot of time in, since it's just re-exporting stuff from proc macro. Maybe you do want to go invest time in that though, but it's a useful proxy. So once you have a sense of which crates are the important ones, you can start digging into them to see if there are areas of concern. I'm sort of just going to talk through my own thought processes on this. I don't expect everybody to agree with this. I think everybody will have their own metrics and their own rubric for kind of what makes sense. But, just as a way of sort of walking through at least some of the things I'm thinking about personally. So here are the 4 things. We'll dig into each one as we go, but, code quality, security, development practices, and sustainability. Well, let's start with the easy one, code quality. How hard can that be? It's actually the hardest one to quantify. If anybody has a good way of quantifying code quality, great. You should probably go do a startup and make a lot of money. Fundamentally, there isn't really a substitute for reading the code and reviewing it. But if you don't have time to do that, you can stand on the shoulders of others to an extent. There are 2 distributed code auditing platforms available in the open source Rust ecosystem. There are probably more, but there's 2 that I know of at any rate. But what do I mean by a distributed code auditing platform? Basically, the idea is that somebody has done a code review, perhaps an individual developer, more likely right now, probably somebody on a team at a large company that's looking at pulling something into a mono repo or into their own development environment. And then they publish the results of that review in a way that can be consumed by others. In the Rust space specifically, there are 2 main tools. There's Cargo Crev. I don't know if it's actually pronounced Crev, but I'm just going to say Crev. And if I'm wrong, nobody tell me till after the talk. And there's also Cargo Vet. Cargo Vet is a lightweight Rust-specific tool that can be used to check Rust projects against known crate audits published by others. Cargo Crev does essentially similar stuff. It's intended to be cross-ecosystem in the longer term, but it's Rust first right now. And it provides a stronger chain of trust and stronger attestations for the reviews. My personal take right now is that Cargo Vet is getting more uptake in practice, but they're both worth looking into, and I'd be very happy to see either succeed and become a standard part of the tooling that we use to build Rust projects. Now, the audits that have been published don't cover every crate, not even every popular crate, as it turns out. But there is some useful stuff out there. So Google publishes their audits for many of their own projects publicly in Cargo Vet format to a GitHub repo. This is roughly what it looks like. It's just a flat TOML format, basically. It's really easy to parse, even if you wanted to do something yourself, but there is tooling available. They also include the criteria that the crates have been reviewed to meet. So for example, for this one, for a hash, it's, they're saying it's safe to run and it's actually cut off, I'm sorry, but it also, there's a does not implement crypto one that they've said in there too. So, that's good. They also have criteria around things like unsafe usage, and levels of auditing there from it has unsafe to we reviewed it in detail and proved that basically the unsafe was safe. So this is useful. Cargo Vet is a command line tool that has its own workflow that's well documented that you can integrate into your own development practices and CI. lib.irs, which is, most of you probably know, an alternative front end into the crates.io database, also actually includes some of these on its audits tab for crates. So for example, it's a little small maybe at the back, but this is the lib.irs view of the recent audits of Surday. So Google has reviewed it as part of their Chromium project and found that Surday 1.02.17, which was the current version as of yesterday when I put this slide together, is safe to deploy, doesn't implement any of its own cryptography, and is considered to be at low risk of undefined behavior caused by unsafe. Similarly, the Zcash project also did a review, and they also found it to be safe to deploy as part of their own review. Cargo Crev also gets shown on lib.rs, again, another command line tool, more complicated API, but probably also more flexible, that you can pull into your own CI. And again, lib.rs will show you the recent reviews it knows of. There aren't any for Surday 1.02.17, but there are some older ones that are, positive, but not very thorough. So, you could kind of figure out how you want to weight those yourself. Beyond that, you can obviously do your own reviews of, things you deem particularly important. That would be a full talk in and of itself. I'm not even going to attempt to get into that right now. And I think everyone in here who has any level of experience probably has their own take on what's critical to review anyway. Probably most of us would agree that unsafe is probably something you want to look at, but things beyond that, who knows? I do want to talk about this a little bit just on a meta level though. Unsafe is an obvious one. Conveniently, I believe Selena spoke about this morning. I haven't seen the talk yet. So, hopefully there's some best practices there that you can pull from that. But I think coming up with a consistent set of criteria of things that you care about is probably a really useful exercise, no matter what, because it will also improve your reviews of your own code as well. And as I mentioned earlier, also build scripts and proc macros, they are things I would want to review as much as possible because they're insidious. They creep into your development environments, into your deployments, into your build environments. So realistically, anything that might result in a file system or network access is probably something you want to examine closely. Now, of course, there are legitimate uses for this. I don't really want to live without SQLX ever again, writing SQL in Rust. But, these are the kinds of things where you have to look really carefully to make sure that they're implemented well. This also raises an important point about technique, which is if you're reviewing arbitrary third-party code, please don't go load it up in your IDE with LSP turned on and everything ready to go, because then all the proc macros fire, all the build scripts fire, and if they are doing bad things, then bad things have just happened. Visual Studio Code has a really useful restricted mode for this. The pop-up is mildly annoying every time I open a folder, but it's there for a good reason, so it's worth the annoyance. And of course, there's other techniques, right? You can view the exact source on docs.rs for every crate. This is useful because it comes out of the actual crate file, not out of the repo. So this is the exact code you have, but there's syntax highlighting and no real intelligence. If you can verify that it matches the repo, which hopefully is something we'll be able to surface in crates.io at some point, you can also view it on the code host. GitHub now has a whole bunch of clever tree sitter based stuff that gives you some level of code intelligence in the code view. But it is obviously dangerous because, if somebody published something just in the crate file and didn't push it to the repo, you might not be reviewing the right thing. But if you know that that mismatch isn't there, that's a pretty handy way of getting some IDE type of facilities without actually going all the way. Also, this is actually one of my favorite tools in the ecosystem, which is diff.rs, which is a website that just shows you the diffs between crate files, crate versions. So this is, for example, the only substantive change in the last version of Surday, which added some sort of enum support thing, which I don't remember. I read the changelog yesterday. I don't remember exactly what it does, But the point is it fit on one screen. And this is a really good way of getting a quick sense. If you've already reviewed an older version, this is a really good way of getting a quick sense of like what changed after that. All right, so that was code quality. That was real simple, wasn't it? Let's move on to security. And specifically, let's talk about security advisories mostly. Most crates that you're going to use have some sort of history. They have done things in the past. Any non-trivial crate probably at some point has had some sort of security advisory, even if it wasn't really an actual like major security problem. The Rust Secure Code Working Group maintains a database called Rustsec, along with a bunch of associated tooling that goes with it, and it aims to be a one-stop shop for security advisories related to Rust crates and the Rust ecosystem more broadly. So you can look up specific crates here. For example, here's the first part of the advisories for the Hyper crate. And then you can click through and, if you've ever seen a security advisory anywhere, basically, this would be pretty familiar to you. What it is, how severe it was, what type of issue it was, when it got fixed, basically. It also includes a CVSS score, which I don't think is actually on this screen, which you probably should ignore. If you haven't read Daniel Stenberg, the creator of Curl's rant about this recently, I would suggest doing so. But the important part here is, in this particular case, 0.14.12 fix this thing. And conveniently, Rustsec provides cargo audit and cargo deny, and a few other cargo subcommands as well, which I'm not going to bother showing. They're all documented on the Rustsec website, which you can, again, put in your own CI actions to basically determine that you are not shipping vulnerable code. For a non-trivial project, you may have to play around a little bit with exclusions. Rustsec is sometimes a little trigger happy on code that is considered to be unmaintained, even if it's not actually vulnerable to anything, but it's a good starting point. I would strongly recommend integrating this into any non-trivial Rust project you work on. If you only do one thing, do this. All right, now let's dive into something even fuzzier, development practices. So it's 2025, and I'd like to pretend that everyone writes code with proper code reviews, perfect tooling, static analysis, Clippy running on everything, etc. But practically, though, we all kind of know it's not true, right? Like, the development practices that happen for code that you don't control, that you don't write, that you're not involved in the creation of, are going to vary. Now, as long as good things are coming out, that's not necessarily a huge problem. But being at least somewhat aware of this is useful. Like having some idea for your critical dependencies of like, how is this crate being developed? What tooling are they using is useful. Because you don't really want to depend on like developed by YOLO as a strategy. Tracking and quantifying this is not trivial. OpenSSF has a concept of a project scorecard that attempts to track various security-related metrics for a project. And this includes trying to quantify various development best practices. A disclaimer, I'm not a huge believer in trying to assign a single score to a complex thing and calling it a day. I think you tend to miss nuance there, and it also just becomes a thing that gets gamed, right? Like, I don't think this particular scorecard is popular enough right now for that to be a huge issue, but in the long run, if it were to be, then people would just try and max it out. But it has a little bit of value, and I'm going to just demonstrate, hopefully, why. So Google's open source office maintains a website called deps.dev that integrates the OpenSSF scorecard into its view of software projects across the ecosystem. And one of the ecosystems it supports is Rust. So it looks at Rust crates. So we can use it to evaluate individual crates. I'm not going to name which crate this is. Not because they're doing anything wrong, but just I don't want social media, anything. But it's a popular crate. So it's apparently a 5.9 out of 10. If you're American, I think that's a fail. If you're Australian, that's a pass, and you're probably pretty happy with yourself. Scaling is hard. Close enough's good enough. Let's break down the individual categories. So we can pop each of these open, and it kind of tells us how it came to this score. So for dangerous workflow, for example, we can see that no dangerous GitHub Actions workflows were detected. That's good. I have no idea how they do this, but that seems positive and sounds truthy. Similarly, this crate is considered actively maintained. It's got good stuff. It's got some commits, some issues got solved. That's nice. But we got to take some of this with a grain of salt, right? Like only 2 of the last 22 pull requests were reviewed. That's terrible. That's not best practice. Anyway, I went and looked at this crate's PRs, and the reason for that is that the 20 of the 22 were written by the crate's primary and only maintainer. And it's essentially a single author project. So the fact that they didn't get that little green tick in the GitHub UI on the right-hand side probably doesn't matter, right? So this is where the nuance comes in. You actually have to do a little bit more digging than just looking at the score. I'm not going to go through the rest of the categories. They're not all created equal, although I think they're weighted equally. One of them checks if there's an OpenSSF badge in the repo README, which probably isn't a useful metric. Sorry, OpenSSF, I know you partly fund us, and that's really nice, but I don't think that's necessary. So that's kind of why I don't place a lot of stock in the overall score. But it's a useful first step to see if there are things that need further investigation, like that code review thing. More data can't hurt as long as you know what to do with that data and when it is lying to you, basically. Okay, finally, let's talk about sustainability. I have a whole 25-minute talk on this that I've given 5 times in the last year that I'm not going to attempt to squeeze into the remaining time. But my contention, the TLDR, you don't have to go watch it now, is that dependencies are generally safer if they're maintained by people who have the time and resources they need to focus on appropriate maintenance and care. If you can identify, say, half a dozen crates that you depend on more than anything else, one of the most useful things you can do is to make sure that they are being supported in a sustainable way, that they're not actively burning out their only maintainer who has just rage quit in a GitHub issue kind of thing. What that actually means differs in practice. If you work for a company with a sponsorship budget and one or more of those crates accept sponsorships or authors, consider kicking them some money. Money can be exchanged for goods and or services. This is useful. Also, if you work at a company that is hopefully not making massive losses and doesn't have a sponsorship budget for open source software, please consider asking about it. I know multiple people who have gotten budgets for this kind of thing just simply by asking the right person in their management chain. And we're not necessarily talking huge gobs of money here, but even just kicking a little bit to maintainers can make a huge difference. If a crate that's key to your work seems to be struggling with other things, maybe bandwidth to review issues or triage bugs or write documentation, you can also look at obviously in-kind support as well. And then you have the bonus that you've become an expert on that crate, at least to some extent, which means if there is a problem in the future, you're in a much better position to deal with it. Obviously, though, this isn't always possible in reality. Again, I work for a non-profit, but improving the lot of crate maintainers where you can, in my opinion, only help the security of your project and the Rust ecosystem as a whole. All right, finally, section 2.5, because it's not going to take 15 minutes like the previous ones, is crate selection. So a lot of the time when you go to crates.io and you type in a keyword, you get multiple crates that do the same thing. For example, if you want to tell if something is false, you have 2 options. How do we choose between them? All of the things I just talked about are obviously part of that. But there are other things that we might want to consider when doing that initial selection. So popularity is an obvious but slippery metric. So this is a crates.io screen. I've sorted it by recent downloads, which is probably the most useful sorting option on the search engine because relevance is not always relevant. Knowing that Elasticsearch is the most commonly downloaded crate for the keyword Elasticsearch is probably useful. But download counts, GitHub stars, etc. can all be gained and can be skewed, by CI practices as well. If one big tech company has a big open source project that re-downloads all of its dependencies all the time, then maybe you're just getting a false signal there. So, another thing you can look at is provenance. In this case, the Elasticsearch crate comes from Elastic, the company, which means it's probably not the worst possible choice. Doesn't mean it's necessarily the best possible choice. I think we've all seen AWS, the AWS ecosystem of crates. But it's probably, you're not going to get fired for picking it, right? There's hopefully at least people at Elastic who are getting paid to actually maintain this and do sensible things. Unfortunately, this does require a little bit of digging in the current Rust world. We obviously have a flat namespace for crates. There are pros and cons to that. But what we don't have is any sort of verified tick, right? There's nothing on the crate search page that says, yes, this was done by Elastic. Again, I don't know if we actually want that or not, but you kind of have to go digging that. But clicking one level deeper and just looking at the repo and looking at the upstream owner usually teases this out. I said I'd come back to this. Something I mentioned earlier that I think is also potentially useful, the good curated list of like, here are some crates that are good to build on top of. So there's bless.rs, which is one view of this. There's Awesome Rust, which is part of the Rust unofficial organization, that also extends out into not just crates, but other Rust resources as well. There are some useful links in there. Now, having something be included on these kinds of lists doesn't, of course, mean that they're forever trustworthy or perfect. But they are useful signals that can be used with other signals to consider what you pick when you're at that like greenfield stage of like, I just need something to talk to an Elasticsearch server or something like that. Fundamentally, the price of a secure supply chain is constant vigilance. But the good news is that the vigilance is to some extent a distributed tasks. Various entities, non-profits including OpenSSF, Alpha Omega, the Rust Foundation, along with for-profit entities like Google, Phylum, various other, mostly hopefully Rust Foundation members, are working to detect as much as possible and publish that data in ways that can actually be reused and integrated into workflows, into CI, into GitHub Actions. At some point, eventually, if something's critical enough to you, you do probably have to do some of your own work, but you can stand on the shoulders of that work that's being done out there. And also, be aware that there are entities out there and people out there looking for bad actors and looking for malware and trying to keep the ecosystem secure. And we're not perfect and we're not going to catch everything, but at least there are people watching. So hopefully this talk has introduced you to tools and work that's going on that can help inform your choices, inform how you develop and make good choices around crates and the Rust ecosystem in general. And with that, thank you very much for your time. I don't know if the slides are particularly useful, but if you want to grab links or anything out of there, that QR code will take you to the slides. We do have some time for questions, but we're also coming up on lunch, so I won't be offended if you sneak out quietly out the back because you're really hungry. So thank you. Toby, you got anything?
Hey, I was going to ask, do you think that the Rust ecosystem would be more secure or less secure if we had namespaces to our crates.io?
I feel like whatever answer I give is going to result in somebody bursting through that door Kool-Aid Man style with just a can of petrol and just like all over me and just set me on fire. I think, so I actually have a whole nother talk on the philosophy of namespacing. I think if implemented correctly, it would probably help, be a net positive. What correctly means I probably have, well, I know I have a different opinion on this to Toby, who has a different opinion on this to Carol, who has a different opinion on this to various other people. And I know we don't have consensus on this right now, which is kind of why we are where we are. I think the thing that I touched on this a little bit a couple of minutes ago, right? I think the thing that would make a difference here, and it's not necessarily namespacing per se, it could be orthogonal, but it's kind of related, is maybe a little bit of a stronger concept of provenance of where crates are coming from and who is maintaining them, and figuring out how we can surface that more in the crates.io UI to help people make better decisions. Which is a really hand-wavy way of saying, yes, probably, but I have no idea how to do it. I'd say hopefully that helped, but I'm sure it didn't. Yes.
For Rust, right, which has a package manager, pulling in other crates is very easy, which means that you're pulling in crates and their crates pulling in crates, fine. But other than sys crates, which maybe opaquely wrap some other language code, this seems to be, naively to me, maybe one of the only vectors of attack. How does Rust security compare to other languages like, say, Python, where you're not only pulling in Python, but that Python might not be Python at all, and good luck getting someone to, I don't know, investigate whether you have a malicious Fortran code in the hood.
Those dirty Fortran developers from the 70s.
All three of them.
I don't think there's a huge amount of difference. I think sometimes it can be a little seductive to us to think that like the only possibility of non-Rust code doing bad or Rust code doing bad things is syscrates or unsafe. But I mean, there's nothing that actually forces somebody to put, the -sys suffix on a crate that pulls in other code. Again, the unsandboxed, I would maintain this was a mistake, but we can't litigate this 12 years later. Like the unsandboxed nature of build scripts and proc macros at present means there's just unfortunately quite a lot of avenues for this. So I don't think it's significantly. I think it's easy for us to say, okay, if you're just using safe Rust code, then everything is definitely good. But you can write, you can write malware in a build script in completely safe Rust. And so I think as much as I would like to say, yes, everything's great, Rust is definitely better, I don't think it's significantly different in terms of security posture to something like a Python or a Node. I think the only difference is that right now we have the advantage of being a little bit less popular, which in theory might give us some runway in the next couple of years to improve tooling and to work towards actually having a safer ecosystem. But I don't think, I think it would be dangerous to assume that we do just because we're Rust and we're safe. Does that answer the question vaguely? Yeah. Did you have a follow-up? Oh, okay.
You mentioned SBOM, and without sharing my own biased opinion, do you see any way forward that makes software bill of materials into something useful rather than a performative exercise in preemptive victim blaming? Thank you.
I think I think the bias that you tried to mask there is pretty similar to my own, actually. So SBOMs as a concept, no, not really. Like I don't see them. I think the only aspect of them I think is potentially useful is having standards, and I wish there was one, but there's at least two, for SBOMs to integrate into other tooling that can do sort of the analysis, some of the analysis work and some of that exploration for you. But that's not really intrinsic to SBOMs as a concept as advertised by a lot of the people in that industry. For Rust, that little lock file would pretty much get you to the same place. So I think it's one of those things where I don't think it's actively harmful. I don't think there's a ton of net benefit, but I think the idea of having just a standard that can play with tooling that's out there, with services, and probably most importantly with certifying bodies with hoops that you have to jump through to fulfill contracts or to do things. It just kind of is what it is, I feel like. So not really, but I don't think they're actively harmful. I don't see a ton of net benefit either. It's like a plus 0.1 kind of thing, right?
Thank you for the talk. I was just wondering if there's been any kind of recent developments around the build.rs block macro stuff moving into WebAssembly and kind of technical efforts to do that outside of simply just auditing everything.
I am not the right person to ask about that. I am sure the right people to ask about that are on Zulip or the internals forum. So I'm not going to attempt to really answer that. I will say that I've been involved in conversations around in the longer term, beyond sandboxing, could we do something that's less Turing complete and more declarative and something like that? But geez, it feels like multiple editions away right now. So yeah, I know there are people working on this. It's not something I'm personally particularly involved in at present. Sorry. Yeah.
So this is a half-formed thought, but I'd be intrigued if there's anything out there. So one thing I've considered for quite a while is there could be a useful flag, to my mind, and you can tell me if it's wrong, which would also be interesting, is something simple as this crate uses the file namespace or this crate uses the network namespace.
Yes.
And that would flag an awful lot of stuff that you wouldn't expect to do it.
Yes. So there is work going on this. It's not super Rust specific at the moment, but Alpha Omega are working with, I think, Google, and I'm trying to remember who the other stakeholders are, on a thing called Caps Lock, which has started in the Go ecosystem as a sort of capability sandbox kind of thing, where you kind of I don't know if anyone's familiar with OpenBSD's pledge syscall, where it's you basically say at program startup, I'm only ever going to access this set of syscalls. So I want the file syscalls or the network syscalls or whatever. It's kind of, I think the intention is to eventually build something that's kind of along the same lines, but more generally. That's certainly in terms of Rust, that's sort of as far as I know, a very, very early stage right now. I think it's basically being like casual conversations in meetings sort of level. But it's definitely an area that I know, companies and people in the ecosystem are very interested in exploring in the next year or two. So no, not a bad idea at all. It's hopefully we'll get something along those lines. All right, going once. Going twice.
Thanks so much.
Oh, thanks.